Okay, so we got a great question here. Section 7.2, section question 8. Waleed asked this one. Thanks a lot, buddy. So this is a rhombus, right? Kind of a square rectangle that's been shifted, square in this case. And each side is the same, 1 meter, 1 meter, 1 meter, 1 meter. So we're going to say each side, or S, is 1 meter. Then we're going to realize that each corner there's a charge Q1, Q2, Q3, Q4. There's a charge there on each little corner, and that's 1.0 times 10 to the negative 6 coulombs each one. We're going to draw a diagonal to help us understand this rhombus, and we're going to draw the long diagonal. See how there's this other diagonal shorter? We're drawing the long one here. Doesn't matter which one you do to start, but I decided to go with this one. Now, we're going to call this diagonal's length little a, and we know that diagonals of a rhombus bisect the angle. So this whole angle was 45 degrees in here. So that means this is 22 and a half here, and 22 and a half here, 22 and a half here, 22 and a half here, and I think you can all figure out that A has to be 135 degrees. Now what we're going to do is use cosine law to find out this longer diagonal, which I've called little a. So I'm not going to teach you cosine law. You all know cosine law. Here it is. You plug in the numbers, and you get that the longer diagonal is, let's say, 1.85 meters. Okay? Now, I'm only going to, the question asks you to find the electric force on each charge. Let's just pick one. Okay? Honestly, when you're doing this for homework, just pick one. It's basically the same thing over and over again. You might have a different diagonal, but same thing over and over again. So what they're asking us to do is find the electric force on one of these charges. And here's the equation for electric force. K, one charge, the other charge divided by how far apart they are squared. So let's take a look at the electric force on charge 2. So we establish our Cartesian plane, x hat, y hat, and the electric force on charge 2 will be caused by the electric force from charge 1 onto charge 2. Here it is, it's in red. So since charge Q1 is over here, it's all along the x direction. Now, the electric force from charge 3 onto charge 2, that comes along this line here, along one of the sides. So I've drawn it right there. Electric force from charge 3 onto charge 2. It's in green. Then along the long diagonal, this 1.85 meters, is the electric force from charge 4 onto charge 2. The electric force of charge 4 onto charge 2, and I've drawn it right there in blue. And we have to recognize that that in here is 22 and a half degrees between the red vector and the blue vector. All right, between x direction and the blue vector, that's 22 and a half degrees. And between the x direction and the green vector, that's 45 degrees. 22 and a half degrees, 45 degrees. So now what we're going to do is we're going to find the magnitude of each of these electric forces. So that's what I've got here on the side, right here, right? The magnitude of the electric force from charge Q1 onto charge Q2, right? We know that the distance from charge Q1 to charge Q2 is a side length, s squared. And we know these charges, and you can calculate that. Now, the electric force from charge Q3 onto charge Q2, right? We want the magnitude of that. K, Q3, Q2, and we also know that they are separated by a distance which is a side length, that 1 meter. So it would be the same since the charges are all the same. Now along the long diagonal, the electric force from charge Q4 onto charge Q2. Here I want to find the magnitude K, Q4, Q2, but now it's not a side length, it's the diagonal length. So we've got that right there. Okay, so now we know the magnitudes. Since we know the magnitudes, we can now start to use component method. We know that charge from Q1 onto Q2 is all along the x direction. So here it is here, and now I'm going to break it down into components, and it's all x. So it would be the magnitude of charge Q1's electric force on charge Q2, and we know the magnitude. Now we're going to do force electric from charge Q3 onto charge Q2 in green. So I need to know the magnitudes, which I just calculated. See, here's the magnitude, here's the magnitude. But now I need to know the geometry of this. Well, it's just 45 degrees. So I'm going to break this green vector into its components based on 45 degrees. They're both in the positive direction. Look, positive sign, positive sign. And since it's 45 degrees, the x component will be that magnitude times cos 45, and the y component will be that magnitude that we calculated, right? We calculated that magnitude times sine 45 degrees. And look, both components are positive. Look, green is all positive. Positive x and positive y. And similarly, we're going to do that for the blue vector here, except now this is 22.5 degrees and the magnitude is changed, right? Here's the magnitude. So for charge Q4's electric force on charge Q2, we get the magnitude. The direction is positive, but now it's cos 22.5 degrees on that. And the y direction positive, right? But we have sine 45 on that. And then it's like collect all the x magnitudes, put it in here, collect all the y magnitudes, put it in here. You guys can all add. So I'm not going to do that for you, okay? But that's how you do it. It's not a hard question, I don't think. It's just long. So don't do all four corners. Just pick one corner like I did, and you're gold. Well, you kids are gold anyways. You guys are awesome. Okay, there you go.